So good afternoon, everyone. We will continue with the service-oriented architecture in this lecture. Last class we discussed about the services, as well as the web services, and the formal architecture, formal service-oriented architecture. Like we discussed about WSDL, right? Web Service Description Language, WSDL. We also discussed about a very popular RESTful API, REST, right? And I also told you the details about SOAP, which is a replacement over the REST, which is Simple Object Access Protocol. And I also told you about the web service hyphen star, right? So there are a lot of services are there. Based upon the requirement, you can obtain one of the services from the cloud service provider. I also told you this service-oriented architecture is started from the grid computing perspective, it is not initiated in the cloud computing. The same thing is taken by cloud computing from grid computing, but initially it is made for the grid computing. So in today's lecture, I will tell you about some of the history part and what are the applications available in the service-oriented architecture, how it is incorporated, what is the interface, how you can interface to service-oriented architecture. That part we will discuss in today's class. So we'll continue our discussion with the same topic, that is services and service-oriented architecture. So whenever we are talking about enterprise multi-tier architecture, you have studied from the network, you have studied about OSI/ISO reference model. You have also studied about TCP/IP protocol suite, right? So if you see overall, if you see, there are two things we are using. One is called as multi-tier architecture, another is called as multi-layer architecture. Okay. So if you compare these two, multi-tier architecture and multi-layer architecture, so multi-layer refers to the logical layer, but multi-tier architecture refers to our physical layer, right? So in network also you may have studied there is a one-tier architecture, two-tier architecture, three-tier architecture, like that you can go up to n-tier architecture. So what is the main purpose of moving from one-tier architecture to two-tier, or two-tier to three-tier, or three-tier to n-tier? What we are doing, like imagine that in OSI/ISO reference model, you have 7 layers. Instead of 7 layers, if you go to the TCP/IP protocol suite, it is 4 or 5 layers. So whatever responsibility you have obtained in the 7 layer, the same responsibility is possible in 4 to 5 layers, right? Same responsibility. Only what will happen? Just like if you want to do a particular work, for that work you have deployed 7 people. So you can say the load is divided into among the 7 different people, right? But if I'll tell them no, you manage this work with only 4 people, then what will happen? The responsibility of the person will be increased. Because 7 people you have divided, now you will divide with only 4 people. So that is the basic goal, whether go for the multi-layer architecture or multi-tier architecture, our basic objective is to divide the work so that what happened? If you see the security for context also, earlier what happened? All things are managed by a single component. If all things are managed by a single component, attack is very easy. But if the responsibility is divided in among different tier or different layer, then what will happen? You have to attack each and every individual component in order to get the complete system, in order to get the information about the complete system, right? So that is the purpose. In order to, although if you go for a multi-tier or multi-layer architecture, the complexity will be more. But the things is that it is secure, and if there is a maintenance is also required, you have to focus on that component only rather than looking the complete system. So that is the purpose of going for this multi-tier architecture. And also we discussed about two different architecture, distributed architecture. Distributed architecture is like a client server architecture, or it can be treated as our P2P architecture, peer-to-peer architecture. In client server architecture, you know, client initiates a request, server replies with that request, right? Or server is going to reply to that client based upon the request, right? So that is called client server architecture. But the problem is that again there is a superiority concept is coming, right? Because server is more powerful than client. But if you go to the peer-to-peer architecture, so in P2P architecture, what happens? All the systems are autonomous systems. They are not dependent on each other. So you can say each and every one is treated as an independent system. They are collaboratively doing the work, and if one work is assigned to the system, the group of systems, collaboratively they are solving that system, and finally they are getting the. A very good example also you can take. Suppose we are going to the restaurant, right? If you take a non-technical example, if you are going to the restaurant, right, we are giving order. Okay, we are watching the menu. Based upon our choice, we are giving the order, right? Then the order will be delivered by the restaurant people, right? So this architecture is called as our client server architecture, right? Because you have requested based upon the requirement, and somebody is providing food to you. That is called as the client server architecture. But whenever you go, whenever you want to prepare, you have let's say you go 5 people in your hostel, you want to prepare some food. So somebody may put the potato, somebody may do put the tomato, something like that. Each and every responsibility you will divide so that combinedly you are preparing the foods. That can be prepared in a P2P system if you see in a non-technical perspective. So if you go for such architecture, the architecture is separated using various layers. Like our OSI ISO reference model is also having layers, right? Or they have each and every layer has a responsibility. They are dependent on other layer, or one layer is giving input to other layer, or one layer is giving one layer's output is going as an input to another layer, right? One layer is is cooperating another layer to provide the service, right? Similarly, in this case, if you see, there are three different processes, or you can say tier. One is presentation, second one is application processing, third one is called data management, right? So, although it is a three views is given in this particular slide, but you can generalize to multiple architecture. For example, if I go for three-tier architecture, then I can go for presentation, application processing, and data management. Somebody will say that no, I'll split the data management into two levels. So it will change to a four-tier architecture. Like you know that there are a lot of servers are there, right? One may be a database server, another is application server. Like that, there are so many servers are there, right? So what we will do? One layer will be taking care of the application server. Another tier may be dedicated to the database server. Similarly, whenever a service is requested by a particular user, right, to the system, so in that case, web service is there. Web service can also be treated as a particular layer, right? But why we are interested in this multi-tier and multi-layer architecture? That is a very question, right? So that's why I have given a very clear-cut thing here. If you go for a traditional system, let it be a two-tier architecture, or you go for the traditional client-server model, what will happen? If something will some problem will happen, right? Then what will happen? You have to make the server offline, right? So if there are 5 servers are there, if one server is not working, then what you have to do? You have to manage everything with 4 servers. You have to make one server offline, and you have to repair it. You have to upgrade it, and any kind of applications you want to deploy, you have to do after its upgradation, right? Or you can upgrade, and after that you can launch a new applications. So the things, whatever you can see, whether it is a fault tolerance, it is a disaster recovery, or clustering, everything is dependent on the administrator. Okay, just like also we have already seen what is the difference between the traditional IT infrastructure and cloud computing. Right? In traditional IT infrastructure, if you see, everything is managed by a particular organization. But if you go to the cloud computing, such things will be managed by the cloud administrator. So as a user or as a customer, I need not bother about that particular thing. So I will focus on the application deployment rather than going for whether a physical infrastructure is available or not, right? So similarly, if you go for a three-tier system, I told you we have three different things. One is presentation, another is application processing, third one is data management. So obviously the layer which is available in the top, that is close to the user, just like our application layer. Your application layer is not there, they are calling presentation layer. So presentation layer is responsible for that particular thing. User, whenever a user is interacting with a particular system or seeking some kind of service, so it has to initiate the request to the presentation layer, right? So presentation layer, what happened? There are external entities are there. External entities, you can say user is external entity, or a broker is an additional entity, or another cloud service provider who is having scarcity of resources, that can be also treated as our external entities. And they are allowed to interact with the system through the presentation layer. The second layer is our business and application layer, or a middleware layer. I told you repeatedly that the middleware layer is hiding the complexity of the infrastructure. It is having user authentication or query processing. Exact, the main work is done in the business or application logic layer or the middleware. There we are managing everything. Presentation layer only receives the request and giving that request to the business process layer to business or application layer to process that. The middleware is generally initiated to provide a single system image. It is giving, you can say, middleware is reducing the complexity of the infrastructure, right? So user authentication, whether the request is coming from a genuine user or not, okay, whether any intruder or any hacker is accessing the system, everything will be managed in the middle layer, that is our business or application layer, right? The third layer is our resource management or data layer. Generally, the bottom layers are the hardware layers, like our physical layer, data link layer, if you see. They are more relying on the hardware. Like physical layer is responsible for our transmission medium, like whether it is a guided medium or unguided medium, that is coaxial cable or fiber optics. These things are coming in the bottom layer. Similarly, in this case, if you see, the bottom layer implements different data sources of an information system. Okay, basically the hardware, storage, and computational powers, whatever you are achieving by the hardware or by forming a particular cloud, that will be managed by the resource management. So these are the three tiers we are maintaining: first tier, second tier, and third tier. But it is not limited to that. Sometimes what happens, we can split a particular tier into two different tiers in order to claim that it is fourth. For example, if you see here in this slide, also I mentioned, if you compare three-tier architecture with two-tier architecture, what you will see, application logic is separated from the resource management. So whenever you go for the two-tier architecture, the first layer is the presentation tier, okay, or presentation layer. The second one is called as a resource management layer, right? So the middle layer, that is application logic layer, or we call it as a business logic layer, or we call it a middleware. The responsibility given into the middle layer in the three-tier architecture is handled by that resource management layer in a two-tier architecture, right? So if you go on generalizing this one, sometimes you can see you are going for a three-tier architecture. Okay, see here the complete three-tier system. I told you presentation layer, the user is interacting, or presentation layer is interacting with the external entities. The external entities means the user. How you are interacting with the user? Through a web browser, okay, or a client is initiating the request through a web browser. So the presentation layer is close to that. And the client general request for the services, right? Whenever you are accessing the cloud, what you can do, they are requesting for the services, right? So you can see these web services and web server are present in the presentation layer, right? Which can also be divided. Somebody will say that I will take web services one layer and web server is another layer. In that way, you can generalize from entire architecture to n plus one tier architecture, right? You can also see in the bottom layer, if you see the bottom layer, file server and database servers are present in the last layer, that is the resource management layer or the data storage layer, right? That is a tier, we can say tier, right? So what you can do, you can also separate it, right? File server is one layer and it is database server layer, so that the three-tier architecture can be put to two-tier architecture. So if you go for a generalized one, you can say the entire architecture is generalized to n minus one tier architecture. So let us discuss what is the comparison of 3-tier with 2-tier. Like in the previous slide, I told you the difference between the 3-tier to 2-tier. Similarly, you can compare a 3-tier architecture to n-tier. So if you want to, here n-tier means we are going for 4-tier architecture. Data tier is split into data storage tier and another data access tier. The bottom one, this data storage, you can split. This data storage there, you can split into two parts. One is storage and another access. Then you can say this 3-tier architecture can be converted to 4-tier architecture, right? So entire architecture, if you see, it is having more simpler, right? Because by dividing the components, security perspective, it is hard to crack, right? Because you see that total n components having any responsibility. So I do not know which responsibility is weak, which responsibility is strong in order to access the things in a particular system. But if there is a single system is there, the security can be easily be compromised. But if you go for multiple systems, it is difficult to get. Even if you are getting, you are not sure that whether you are getting the correct information by the help of that particular file. Okay, that is the entire architecture. So they are also suggesting that the web service also can be seen as another tier in the top of middleware. So here you have middleware, right? So what you can do, the presentation layer you split into two parts, and you can keep a web service as a layer and a web server as a layer, right? So that you can enhance from one tier architecture to one plus tier architecture here, right? Now, before going to this OGSA, just I will show you another slide to clear the idea. So here you can see the same thing, whatever we discussed, that clearly the same thing is written here. I hope this slide is visible. Is it visible? This slide is visible.
Yes, sir.
I have taken this slide from one of the very renowned author. Like you can see here, what I want to discuss, whatever we discuss, presentation layer, application database logic layer, their clear cut example is there. Like presentation layer is the user interface is there. In application layer, we are middleware is there, right? In the database layer, you can access the data, you can store the data, right? So that is managed layer, database logic layer. So what I want to show you in this slide, yes, this is you can see in a one-tier architecture. If you see, one-tier architecture is nothing what called as the dumb terminal. Dumb terminal means all the responsibility is managed by a single system. You can assume that you have a mainframe computer system. In the mainframe computer system, you are doing all the works, right? Then you can say that is a one-tier architecture. All the responsibility is maintained by that tier only. So in order to solve this problem, but that is not good, right? In the security context or in order to achieve a good performance of a network system, one-tier architecture is not sufficient. So what we are doing, we are going for two-tier architecture, also called as flat architecture. You can see we are dividing the entire responsibility to two tier. One is client tier and another is for server tier, right? So you divided the responsibility. Now client will be seeking some request to the server. Server is providing the services to the client, right? This two-tier architecture. So let us see the three-tier architecture. If you go for three-tier architecture, here you can see here the server means we are pointing to the application server, database server, and whatever service is required, whatever resources the client is requesting, accordingly each and every server is managed in a single tier. So in three-tier architecture, what we did, the server is now split into two parts. One is application server and the database server, right? So application server, we are interested for the whatever resource you have requested, right? And that request can be given to a particular client by calling the database server, right? So database server is going to provide you the application server with the data they require. Whatever applications you are deploying in the cloud, each and applications having the related data, you can access from the database server, right? Similarly, you can go for entire architecture. Here, what happened? Again, application server and database server is there. Some other servers also you can separate it in tier 4 or you go for tier 5, tier 6 like this, right? So what happened in each and every case, the client is interacting with the application server only. But application server is backed by various servers, right? And each and every connection is treated as a client server interaction. Every time, whenever you are making a request, So a server may also request to another server. Like you can see in this slide, the application server is requesting to the database server. The database server is going to provide it, right? So like that, the process is going on to achieve a better performance in the network system. So I'll save this slide and you can go through it. Before finishing this particular slide, I want to discuss another very important concept. You can see here. Here, there are basically we are discussing four different parts. One is called as the host-based processing. This host-based processing is done in the dumb terminal. Let us consider the mainframe system. I told you in the logical tier, what happened? We are dividing everything into three parts. One is presentation, another is application, and database. So each and everything is managed by the DOM terminal only. Right? You can see if there is a terminal. That terminal is responsible to do all the works, right? User interface, middleware, query, authentication, authorization, okay, or data storage, data access, everything will be done by the mainframe computer system. So in order to avoid this one, what happens? The server-based processing starts. When server-based or client-based processing is started, so people are also talking about thin client, fat server. Generally, we are doing the reverse thing, right? That is, when if you pick a thin client, you pick a fat server. If you are going for, let's say, head client, then you go for a thin server. So you can see here what they are doing. In case of thin client, the client responsibility is less in comparison to the head server. So what happened? Application logic layer and database is the responsibility of the head server. Okay, but presentation is the responsibility of the client. This presentation, the responsibility is now divided among the client and the server. So if you see in this context, the client has less responsibility than the server. That's why client is called as thin client, server is called as fat server, right? Or it may happen that here they are cooperating among them in the presentation context, but in this case, if you see the presentation is handled by the client, but rest part is handled by the fat server. Okay, so this is the combination between the fat server and the thin client. So these two systems is possible in the case of server-based system. Coming to the reverse one, if you go for the reverse one, here you can see the client is managing the presentation and application, but the server is managing the database. Okay. So the more responsibility is given to the client. That's called as the head client. But if you see the server term, server is only handling the database. That's why it is called as thin server. Or in another diagram also you can see presentation application is there and database responsibility is distributed among the client and server. Right? Both are responsible for the database, but presentation and application is explicitly given to the client. Right? Apart from the server-based processing and the client-based processing, we have a cooperative processing. If you see in the cooperative processing, what happens? The application is now managed by both client and server. The presentation is managed by client and server is managed by the database, right? So this type of system is called as cooperative processing. So while you are going for SOA architecture also, you have to decide which architecture or which tier architecture, which layer architecture is suitable for modeling, right? So please go through this particular slide. Okay. The second point of discussion in today's class is about OGSA, right? So I told you about some class. I told you about BOINC project, right? That is Berkeley Open Infrastructure of Network Computing. And if you go for this BOINC platform, in this BOINC platform, you have a lot of grid computing project which is managed by University of Berkeley. So that is a grid computing system, right? Grid is generally meant for the voluntary services, right? Grid is not meant to make business, right? Like cloud computing, we are only focusing on the business, right? How best we can provide things to the customer, right? If customer is agree in that services, then we can generate revenue, right? But grid computing is not meant for that. Grid computing is meant for voluntary one. Later, they plan to get business perspective they discovered or they coined the cloud computing, right? If you go for this grid, there is a architecture that is called as open grid service architecture. Okay, and there is a working group like we have GitHub. Whenever we want to see a particular code or we want to post a particular code, we are referring to GitHub. Okay. So similarly, there is a OGSA working group of Grid GGF we call, that is Global Grid Forum. Earlier it is called as OGF, that is Open Grid Forum. So they developed this working group has developed the Open Grid Service Architecture, right? And it is merged with our enterprise grid alliances. Okay, so if you see this OGSA, this is the first one which we call it our service oriented architecture. The main purpose is that why to manage different components. Like I told you a very good example, that is Flipkart. Whenever you are placing a particular order, it is the order is going through the multiple components, right? But user did not bother about this component. That well, the process will be done not just like a workflow, but user need not bother about that particular thing, right? So what we are want to do, we want to define a common standard and open architecture for grid-based applications. So here open means we want to develop a particular standard, or we want to define some rules and regulations in the standard which can be easily processed by each and every architecture. And if you can say with respect to the cloud service provider or with respect to the organizations, these standards will be unique one. Just like we have seen that service level agreement also needs standardization, because moving from one cloud service provider to another service provider may lead to the lock-in problem, right? So in order to avoid that, we want a common standard in each and every provider, so that moving from one position to one cloud service provider to another cloud service provider is very easy. So OGSA is intended to facilitate use and management of resources across distributed and heterogeneous environment. And they are also providing the various quality of services like reliability, availability. Okay, there are a lot of quality of service factors are there. These quality of service parameters are satisfied by OGSA. And I told you about the Globos toolkit in the last class. You explore this Globos toolkit 4 or Globos toolkit 5. So in this kit also you can see, you can explore this OGSA architecture. So these are the things provided by OGSA. OGSA is defining an open standard interfaces. Interfaces means we cannot directly interface with a particular server of a data center, right? So whenever you are making a request, the request is reaching to the cloud service provider through an interface, right? Then cloud service provider has a load balancer or a scheduler which decide that which resource is going to be allocated for as per the requirement, right? So there is a interface is required. We cannot directly reach to a particular resource. And there are a lot of integration techniques are there. Sometimes we are following the standards provided in various industry. Okay, like IEEE has done so many standards. If you have studied the software engineering, you know lot of standards are defined. So that standards, if a standard is there, then you can say that you can cross with a particular thing, right? Like whenever we are purchasing a particular thing, we are looking into ISI mark or hallmark, right? So from that perspective also you can think, right? So it is developing the standards and it also provide interoperability. Interoperability provides that we can move from one to another thing very easily, right? It is also integrating, virtualizing, managing the services, resources in a distributed and heterogeneous environment, where loose coupling is the main target, right? In the loose coupling system, how we can integrate this system. So I'll tell you about the interface in a small diagram. You can see in this slide. Yes. So you can see a user means a client. You want to access some resources. So the client can access to a particular computer system. The request will reach to the portals. Sometimes we call it a it is called a you can say user interface or portlets. So once it is reached to this one, then based upon the requirement, one of the virtual computing resources is going to be allocated. Or like in the virtualization technique also, you know that you are creating VMs on top of the physical machine as per the requirement of the customer. Or you can take the VM template, right? Suppose somebody is asking 3 GB, but VM template suppose only 2 GB or 4 GB. Then you can create a particular virtual machine of 4 GB, and that one you can provide to the customer, right? So portals and user interfaces are required in order to access the virtual computing resources. Is for the requirements. So this grid service implements one or more interfaces because sometimes a single user interface is also not good, right? Because if the interface is failed or interface is collapsed, then what will happen? Nobody is going to get the services. That's why we say sometimes we are generalizing it to more interfaces. So here you can see each interface. If you see each and every interface is having a set of operations. Like last class, we discussed about the get command, post command, delete command, right? For creating something or updating something or retrieving something or deleting a something, a set of operations is available. Like you have seen in Amazon S3 also, you have given command to create a bucket, upload a particular object, right? So each and every interface can is enable a particular user to choose a particular operations out of the set of operations, right? Then accepting a defined sequence of messages based upon the open grid service interface. Right? This OGSI is also, if you see, is also developed by the Global Grid Forum, right? In order to give this one or more interfaces and in order to exchange messages in the in OGSI. Okay, this is the OGSA architecture. You can see the top one is called as grid applications. The application may be a satellite application. The application may be a molecular application. The application may be related to the healthcare industry. The application may be related to rocket launching or many things, right? Many scientific and engineering applications are there. So it is managed in the very top layer, that is grid application layer, which is close to the external entities, right? Then OGSA is there, right? In OGSA, that is Open Grid architecture, right? Open Grid architecture is there. So here OGSA you can see is responsible for 7 components that we are going to discuss. One is your data service. Second one is self-management service. Third one is information service, infrastructure service, execution management services, resource management services, and security services. And that is your nothing but your middleware. This OGSA is a middleware, right? Then Open Grid infrastructure, what we discussed here, Open Grid services interface, right? So this OGSI is present in the bottom layer, that is the fabric layer. Also the web services, that is WS-star, whether it is related to management or whether it is related to addressing, okay, or it is a resource framework WSRF. These all things are managing in the bottom layer, that is your fabric layer, right? So now let us discuss the services provided by OGSA. So OGSA provided 7 services. What we like to told you. First one is called as your infrastructure services. So infrastructure means in infrastructure you have a lot of resources, right? Each and every resources can be represented by IP address or represented by the particular name, right? So infrastructure service of OGSA is responsible for naming the resources, okay, so that assessing the resources become easier, right? And it also takes care of managing the resources as well. The second types of services provided by OGSA, that is called execution management services. So once a request is reached to a particular architecture, whether it is grid computing and cloud computing, the first work is to we have to see whether we can fulfill that particular request or not. Or if a job is submitted to a particular thing or application is submitted to the cloud service provider, the very first is that how we can decompose the application into number of tasks. If you decompose into number of tasks, because we have a lot of computing resources, what we are going to do, we want to execute these things thoroughly. Okay. So managing the task or managing the job, managing the applications. Okay. Generally, application is represented in the form of a workflow, right? To get a directed cyclic graph. Okay. Such things is managed by the execution management. It is also responsible. Execution management is also responsible for doing the mapping of the task to the resources. Okay, which task is going to be executed in which resources. Placement of the resources is done in the execution management services. Third type of services is called your data management services. So that is nothing but to move the data, right? Move the data to where it is needed. Sometimes what happens, a bulk transfer is required, right? So what we are doing, bulk transfer will take time. So for what we are doing, we want to make the resources available as closer to the need, right? As closer to the need of that resources we want to do. Like in the Facebook case also, you know that suppose two people are frequently communicating with each other, right? If both the users are hosted in two different separate servers, okay, or they are managing in the two different servers far away, in the communication can be more. What happened with a similar interest also, you can put the loads of the resource, loads of the users into the same server. So if you do like this, what happened? The communication time will get reduced, right? So similarly, generally, whenever you are executing a workflow, I'll tell you, whenever we discuss the task scheduling part, so what happens if a parent is executing in a particular resource, the child is also allotted in the same resource. If you allot like this, the communication can be less because parent is going to provide some temporary results to the child. That's why the parent and child are likely to assign to the same child. Otherwise, what happens? The communication can not to bear. So sometimes what happens in order to make the data faster, we are duplicating the data. Duplicating is nothing but the replicating the data. Instead of keeping a single copy of the data, you are maintaining multiple copies of the data. The first advantages is that if the data lost in a particular space, it is not going to affect others, right? That is the first thing. Second, data loss will not be there. Second is if it is available in the multiple sources, anytime in the data transfer or data download is much easier. Like in our when we studied when we are studying at there at NIT Warangal also we have a DC plus plus system. I don't know whether your hostels are configured in that or not. Suppose you want to download a particular movie, that movie is available. Let's say in 10 users are having that particular movie. So when you download the movie will be downloaded from the multiple sources. So within a fraction of second or in 1 minute, what you are going to do, you are going to get that particular movie. You can easily get the movie, right? So maintaining duplicate records sometimes makes the assessing the data is much faster way. Okay, you can update and transform the data into the new formats. Like all the users are not requiring the things in the same format, right? So with respect to the user, their format is different, right? So you have to see that which part you are to make public, which part you have to hide. But as you are maintaining the replication of the data or the duplication of data, once the data is replicated, you have to bear with the data consistency. If the data is not consistent, misleading information may lead to some catastrophic effect as well, right? So integrity of the data, persistence of the data, consistency of the data is coming into picture. So data management services are also having three different interfaces. One interface is used to access the data. Second is the data factory. Third one is the data management. Why these interfaces are there? Because one interface may be used to represent the data, another may be assessing and creating the data, another is to managing the data. The next broad area you can see that is called as the resource management services. Whatever resources a particular system has or a particular architecture has, it needs to be monitored and monitored in a regular interval, right? So that you will know that whether the resources are busy or the resources are free, right? So it also resources can be reserved. Suppose like you have seen in the advanced reservation mode or desktop mode, we have seen various modes in which you can reserve the resources as need. Deployment and configured as needed to meet the application or political service requirement, right? And this services, resource management services is also responsible for the semantics of the data, that is the meaning or the information of the data, and also deal with the data model representation, right? So these are the responsibility with respect to resource management services. Apart from these four, there are other services are there like authentications, authorization, integrity, you can say access control, and these signature things and everything is coming under the security services. So GSA is providing this thing by creating a virtualized environment. This virtualized environment must ensure that the proper authentication should be met. Next is called as your information services. In information services, we refers to the dynamic data or events used for the status monitoring. Sometimes in our computer system also, whenever we are facing some problem, we want to monitor the status. So what happens? Whether internet is available or not, whether a particular port is working or not, we are going to the troubleshooting. So that is called the information services, where a step-by-step process is written, so that whenever you are not able to get the things whatever you want, so you can troubleshoot your system and you can get the services. The last one is your self-management services. That is automation plays an important role. Everything is automatic. No person is deployed to monitor these things, right? That's the automation plays an important role. Automation can efficiently manage these resources, efficiently allot the resources, because you have to focus on the methods, or you have to focus on the designing the algorithm process of your code, right? Then automatically, based upon your logic, what will happen? Automatically, it is going to allot the resources to the customer and monitor the resources. In case of anything, it will report as a troubleshooter, right? So this is the complete architecture what we have seen. So such type of services are provided by OGSA, and it is backed by, you can see, various web services and OGSI. So OGSA has been adopted as a reference based architecture, as it was quite old architecture. So it is on the newly developed architecture for grid, right? Like Logos toolkit is developed. All are referencing to the OGSA. Like in network also, you know that OSI ISO reference model is the first one. So it is a reference model, right? Based upon that, TCP/IP model or some other models are developed in the later stages. So it is the very first architecture. That's why it is considered as the reference grid architecture by the number of grid projects. They are following the OGSA. There are a lot of issues are also there with respect to OGSA. Like timing is one of the issue. Timing means, you can say, as the resources are completely distributed and they are not present in a single place, what will happen about the time zone? For example, somebody is requesting at 2 a.m., but the resource is available yeah, in another different time zone. There the time is 6 p.m. So this monitoring of 2 a.m. is same as 6 p.m. in some other region. You have to take care, right? So with respect to grid projects, there are a lot of challenges are also there. So the first prototype of grid service implementation, you can see in the January 29, 2002 at a global toolkit by Argonne National Laboratory. The first prototype is available by 2002, and 2008 you know that cloud architecture is there. So grid started in the end of 1990s, up to 1990s, and it was emerging up to 2008. After that, cloud computing is popular, and it is back to the grid computing. And creation and destruction of a transient grid services can be done dynamically. So based upon the scientific and engineering applications, what you can do, you can create the grid services. Okay, you can create the grid services. So, for example, in order to execute a scientific engineering applications, I require 1 million of computer systems, right? So what happen? I will create suppose 1 million of computer system. I require for 24 hours, right? So this is a project. This is a project, or this is an application which you want to launch in the grid computing infrastructure. So what happen? I will create a system, create a grid system in which 1 million computer system will be joined. And after one day, suppose I don't require this thing, I can destroy it, right? So that is the way you can create and destroy the resources. And as it is completely voluntary services, right? You can also participate in the BOINC project by installing BOINC into your computer system, right? So multiple systems can be joined and can share the resources, so that the scientific engineering applications which you have registered, so that that the project can use your computer system to execute a particular work. And OGSA applies the WSDL language, that is Web Service Description Language, WSDL extensions to represent the identifiers necessary to implement a grid service instance. So web service is also a quite old term. Like I told you, SOA is not a new term, but the type of services what SOA is providing, it is having a more advantageous one. That's why many advanced computing paradigm is dependent on the our service-oriented architecture. But the main issues you can see here, incompatibility is always an issue whenever you want to integrate multiple components, incompatibility will be there, right? But this incompatibility is gradually solved based upon the lot of integrations or plugins. You can able to avoid this incompatibility. So web service resource framework and WS addressing and WS notification specification have been proposed in UASIS. Okay, you can see in the web service resource specifications contains a lot of things. If you are interested, you can see, like I told you, these WS icons are right. A lot of web services are there. Like here, we are focusing on the resource properties. What is a resource? What are the different properties the resource has? Resources lifetime. Each and every resource has a lifetime to provide the resources. Then service group based calls, various notifications, WS addressing, each and everything is coming in the WS RF. So if you go for a plain service, if I am not interested for a web service, I want to go for a plain service, okay, or you can say plain web services, right? Today's web services is much more advanced, but if you go for a plain web services, it is stateless. What is the meaning of stateless? Stateless means it is not keeping any information about its previous state. Suppose I am doing any kind of invocation, then once the invocation is done, okay, I am doing another invocation at that time, it is not taking its previous states. Right? Previous invocations are not stored. That is the plain service. But what happened today's web services, you know, in our web browser we have a cookie, right? So these informations are also stored in the cookie so that we can faster, we are able to access the various things in a faster way, right? So there this stateless services plays an important role. Our web services is improved in such a way that they are going to provide a faster service in comparison to the plain web service. So these are the specifications. The state information of a web service is kept in a separate entry. It is called as a resources, right? Each and every services is requested to a particular resources, right? So a resource can be resources may have more than one. A service can have more than one resource. Like you are requesting five servers. As a user, you are requesting five servers. That means five servers are having different names or they are having different unique ID. So a single work is done by the help of five computer systems. That's why a server may have more than one resource. So resources can be either memory or persistent or stored in a secondary storage such as file and database, right? Any resource, suppose I want to, a file I want to store in a particular storage device, right? Which is there in the data center, that can be also treated as resources. Sometimes pairing of the web services is also required. Okay, I want to invoke multiple web services at the same time. So that is the responsibility of WS resource. WS resource is responsible to pair the web services. So apart from that, WS addressing is there. You have you can see that the way addressing a specific WS resource is to use the qualified endpoint reference construct and protect the WS addressing specifications. Addressing specification means each and every resource has details, their properties can be maintained in the WS addressing. You can see here also WS addressing. Here the main description is that transport neutral mechanism to address web services and resources. Whenever a web service is initiated by a particular client, how we are going to address such web services and messages, that is the responsibility of our WS addressing. Okay, so there are two examples which with respect to this you can see that with these resources, one is called as the system and another is called small grid. So details about these two we'll see in the later stage. Like US Department of Defense, they are also using these systems, right? They are early days, nowadays cloud computing is popular, so everyone is going for the private cloud. But early days they also need to compute something. They also need to monitor various things. For that, they have used global information grid, right? And they also rely on the various web services. That's why various web services like WS Icon Star and also uses the OGSA. Okay, and what kind of web services they use? That the web services are nothing but with respect to the enterprise service management, with respect to the security, with respect to the messaging, right? Discovery, mediation, collaboration, user assistance, storage application, and environmental control services. And the example of these services and features are also mentioned here. One of the things I am going to tell you that is called as a PubSub model. One is called publish and subscribe model. What we are doing in YouTube, right? YouTube is also we are subscribing a particular channel, and it based upon our requirement and based upon our subscription, the various videos or music are played, right? That is PubSub model. We are going to discuss in more details in the upcoming classes. And security always plays an important role irrespective of the different architecture. So similarly, this grid architecture is also used by CICC, that is Chemical Information and Scientific Collaboratory. So these are the projects. Okay, they may be relying on the small molecular data or large molecular data. So these are the small molecular data available in this particular project. So just an example, we are not going to discuss more details. Like this is a, you can say, real life example where these things are used, right? Where this OGSA is coming into picture. They are also able to monitor the large molecular data, that is RIMA or protein data bank, PDBB bind or MODB. So such things are also large molecular data is also used by chemical informatics and scientific collaboration. Apart from that, there are a lot of examples are there, like CICC is having a lot of service names. I'm not going to these details because the details about the CICC services is not required. So if you are interested, you can go to the various services provided by CICC.